autoways is just as important, if not more, making sure you know when to use this wonderful tool that you have. All right? So, there's Mike's chickens. All right, so here's a whole bunch. Here's a whole bunch of experiments. You decide whether or not you can treat them as binomial. So we did this one in class. Take a die, roll it. Count the number of pips. That's an experiment.
No.
The random variable will be the number of pips on the die. I'm seeing a lot of head shaking no. Probability is 1/6. What's wrong with that?
You win 2 options.
Oh, 6 options. Not binomial anymore. Hexnomial is going to call it that. That's fine. Right. Now, definitely, remember what this distribution is called? It's actually got a name when you roll a single die and you keep track of probabilities, because they're all the same. I thought I mentioned it earlier. Maybe I didn't. It's okay. It's not that important. Starts with a U.
Uniform?
Uniform. That's a uniform. That was on the program. I didn't mention it was in the program. You can actually generate that distribution in the TI if you want to. You probably don't want to because it's kind of a waste of time. Now, how about this?
Yes.
So you bet your friend. I'm going to bet you 5-1. I roll 3. All right? Yes or no on binomial?
Yes.
Yeah.
Hell yeah, it is. Because what are the 2 outcomes?
3 or not 3.
You either get the 3 or you don't get the 3. So you roll a single die. It is either 3 or it is not 3. Beautiful. It is either 3 or it is not 3. That's binomial. What's the probability of success?
1 in 6.
1 in 6. What's the chance of failure?
5, 6.
There. That's what we couldn't do with this one. The chance of success on this one is 1 in 6, but the chance of failure, there's too many chances of failure. You can fail 5 different ways. But if you phrase it like this, which is a different experiment, it's a different experiment, that is binomial. Good. You'll have this power, actually you already have this PowerPoint if you want. It's already uploaded from Tuesday, but it'll be re-uploaded today. All right, here we go again. Okay? 2 dice, just like class. Add up the pips that you get on the 2 dice. Add up the pips.
No.
You seeing some head shaking? No. What's the problem?
You're still getting more.
Ah! Because there's 2 through 12 of the sums, right? 2 through 12 of the sums. This is not uniform, it's not binomial. This one doesn't have a name. It's shaped like this. I don't know what that's called. Absolute value, I guess. Okay? How about
There we go.
rolling 2 dice and betting on 7 or 11? I like different answers for this one. I hear some people saying yes, and some people saying no, and I love it.
No.
I love it. You can see it both ways. Tell me why no first.
You can get 7, 11, or not 7 or
Good! That's one way of viewing it as trinomial. You can say, I can view it as trinomial and say you can get 7 or 11 or not 7 or 11. Neither 7 nor 11. They can try good. That's a perfectly acceptable answer.
Or you could say winner loser.
Or you can say win or lose and make it binomial. So force it to be binomial by saying either I win by getting 7 or 11 or I lose by not. So I can take Carly, I love what you said, make it trinomial, but you can force this if you're not interested in distinguishing between the 7 or the 11. If you're only interested in winning, you can make it binomial. If it's important to distinguish between the 7 and the 11, then no, it has to be trinomial. But if all you're interested, like if you're playing craps. If you're playing craps and you roll those dice at the beginning, it doesn't matter if you roll 7 or 11, you win on the come-out roll.
Then aren't you betting on 7 and 11?
No, or. Because you can't get 7 and 11 at the same time. You have to get one or the other, or like you said, one or the other or neither.
But are you placing 2 bets?
No. You're betting one time, and you're rolling the dice. If you get 7 or 11, you win. If you don't, you lose. No, I'm not saying there's not one right or one wrong answer.
In craps, I don't think that's. I think it has to be 2 separate bets.
No. It's called a pass line bet or a
pass line bet.
You roll the dice. If 7 or 11 comes up first, you win. That's a guarantee. What's the chance that happen? FYI. On the come-out roll, what's the chance of winning?
2 out of 36.
2 out of 36 is the chance of 11. What's the chance of a 7? Do you remember? It's okay if you don't.
Oh, man.
It's in here somewhere. 6 out of 36. So how many rolls are winners on the come-out? 8 out of 36. If you want to make a binomial, that's your chance of winning on the come-out roll. Now, you don't automatically lose on the come-out roll if you don't do that. But if you were betting only on 7 or 11, if you were betting on the come-out roll, 8 out of 36 is your chance of winning. Is that fair? So Carly, I'm not saying you're right, I'm not saying I'm right, I'm not saying you're right, I'm not saying I'm wrong, I'm not saying you're wrong. It's how you view the 7 or the 11. If all you're interested is winning or losing, that's binomial. Fair? You guys buy that? Good. Define the problem. Step 1, always define the problem, define the variables. All right, here we go. We're going to roll 2 dice 5 times. And on each time, we're betting on 7 or 11. So in other words, we don't like the odds of 8 and 36. We don't like the odds of 8 and 36. We think they suck. So since they suck, we're going to bet enough times to make us convinced of something. I'm trying to understand the mind of gambling. Which is why I gave you the quiz for next week. FYI. What do you think? I'll accept many answers for this.
Wouldn't it depend on how you define the problem?
Yes. So how should we define it? Win or lose? So are we interested in only win? Let's keep 7 or 11 lumped together so we know the probability of winning on any given roll is 8 and 36. If we do that, can we make it binomial?
Yes.
It has to be, doesn't it? You're playing 5 times. Compare it to the chickens. Is it the chickens? Yes. The probabilities have changed. You're buying 5 chicks. You're buying 5 chicks. Each chick represents a roll of the 2 dice. If you win, the probability is 8 and 36. That's like the 0.9 for the chicken, or for the girl, for the female. So obviously you'd want to win all 5 times, yes? Which is highly unlikely that you're going to win all 5 times, correct? I mean, it's only 8 and 36. That's once. Doing that 5 times in a row will be 8 and 36 to the 5th power. Now, what's the most likely outcome in this? How many times can you expect to win? On average, how many times can you expect to win? Yes, I gave you the tool for this, friends. You have the tool. Once you've identified it as binomial, you will never ever lose more money than you want to lose in Vegas again. Notice how I phrase that. You will always lose money in Vegas. Admit it before you go in. Use the binomial tool and all the other tools at our disposal that we've used through the term to understand on average how much you're going to lose per unit time. This is most definitely binomial. I know that. Okay? Smallest x?
0.
0. You might never win. It's pretty likely, actually. Largest? 5. You might win them all. What's the chance of winning? That was that 8 and 36 we mentioned before, 8 and 36. It accepts fractions. Oh, crap. I hit the wrong button, sorry. I hit the wrong button. The function is now 6. Pretty boring distribution. Hit the wrong button. Just fill. 0 to 5. Binomial. There we go. 8 in 36. Okay, it's done. Okay, want to look at the graph? Okay, so on average, how many trials do you expect to win?
1.
1 out of, that's one, be careful, that's 1. This is 0. It starts at 0, 1, 2, 3, 4, and there's 5. That's not going to happen. Well, of course it's going to happen. I mean, it's going to happen, let's see, it's going to happen about never. 0.0005, so 0.05% of the time, 1 in 10,000 or 5 in 10,000. It's pretty crappy, pretty crappy, pretty crappy. But your mode and basically your average is up there around 1, but that only happens 41% of the time. Now, if you needed an exact average number, if you needed more precision than that, which, by the way, the casinos need a more precise average than that, they can't accept just about 1. What is the average number of times you're going to win?
1.1.
Boom, how'd you get it? David.
1 bar stats.
Oh, what beautiful, thank you. Stat, calc, 1 bar stat, L1, L2, don't forget that. If you don't want L1, L2, it's going to tell you 2.5, and you're going to get happy and start losing money quickly. L1, L2, yeah, 1.11111. So you actually win a little bit more than 1 time on average over time. Pat?
Okay, now, if you want to do this or play craps, like you can think, you have to know a little bit about craps. You can bet against yourself, right?
Yes, you can.
And the don't pass for the come out rolls.
Yes, you can. But they take the 2 off the table for that one.
That's right.
Why? So,
Because it gives the advantage to the
the
casino.
house. Yeah, so there's, craps is evil. It's an evil genius game. It really, hey, who's played craps? A couple people? It's an evil genius game, it's wonderful. The chance of winning, it's the best game of chance for your money. I actually use craps on the Gambler's Ruin quiz for next week. It's the crap, you're seeing craps probabilities on there, so it's fun. You have a 49, I think, 0.44% chance of winning on a pass line bet. Right. Which is mean you either win on 7 or 11 or you match your point. We can get into this more after class if you want to talk while I walk to my next class. So the 49% chance is a pass line bet, actually a little bit, 49.5%. You could also bet against the roller on a don't pass bet. So So you'd think, well, hell, if he only has a 49.5% chance of winning, that means I have a 50.5% chance of winning. So I bet against them. But they changed the rules a tiny bit. Crapping out by rolling snake eyes works against both of those players. If you crap out as the roller, you lose. And if you crap out playing against the roller, you don't win. And the whole reason they do that, of course, is to knock that probability just a scotch down below 50-50 to keep the money coming in. Craps is genius. Genius. There's so much great mathematics in that game. Sorry.
For the hard way.
Oh, for the hard way. Oh, please. Or was it 10 on Viagra? That's the new one I've heard. Old man on Viagra is 2 double fives. I love that when that came along in the past couple of decades. Did you see what I did up here? I was sneaking this by you while Pat was explaining that. You can also get the average by saying, out of 5 trials, if I win 8/36 of the time, there's my average of 1.11. Notice it only works with the binomial, though. So it works here, it won't work in general. You can't do it for a single die, for example. You can't do it that way. It won't work that way. Fair enough? Good? Okay, good. All right, let's back up. I got a few more of these. I want to get away from coins and stuff because I want to get into stuff that you guys might actually see in your research. So, what's the next one I use? It's Chuck of Luck. We can skip Chuck of Luck. We talked about that already. Here we go. Kind of a socio-psychological, biological question.
Yes.
Vote for yes. Vote for yes.
Yes.
Depending on.
Well, are you counting like red colorblind or green colorblind?
Let's make it all one big thing. Thank you, Jolie. It's all one big. Red, green, colorblind is one condition. Let's call it all one thing. Thank you. It could be trinomial. Let's make it binomial. In that way. So here, yes.
They either have it or they don't.
They either have it or they don't. Binomial. Are they independent trials? Arguably. Arguably, right? Because I'm assuming once you pull a man out of the pool, you're not putting him back in and maybe grabbing him again. But can't you assume that? How many American men are there?
A lot.
Like 150 million? And you're grabbing 20? This is the chickens and the Tupperware. It's even more exaggerated than that, isn't it? Maybe 20 men out of 100 million versus 4 out of a couple thousand, maybe. Yeah, definitely arguably independent. Thank you. On average, how many are going to have red, green, color blindness? 7 out of 10. We grab 20. Or actually not 7 out of 10.
Oh, sorry.
Right, 0.7 out of 10, right? 7 out of 10 would be 70%. 0.7 out of 10 would be 7%. So if we're out of 20, it would be 1.4 out of 20. Does that make sense? Yeah. If you don't like that, which you might not, just simply do 20 times 0.07. Or run one more stats if you want to do that too. You can put this in your distribution. 0 through 20. 1.4, expect 1 point. That's kind of crazy, think about it, right? I mean, a lot of dudes have red, green color blindness. A lot of females don't. It's one of those genetic gender things. Kind of fun. Good? Okay. This is related also to your quiz for next week. Your craps quiz. I love that quiz. Is that end projector in the way? I'm sorry.
No.
Yes, it is. Or yes, it is. I got you. Yes, it is. Yes, it is. Yes, the projector's in the way, and yes, I think it's binomial. Read the wording very carefully. I've made it so it's not.
Yeah, because you say you keep.
It still sounds binomial, doesn't it? Because you either do or you don't. But Monica.
But they're not.
You say you keep selecting men at random. You're not.
It's not independent.
Yeah.
Well, they might still be independent. Maybe it might not. We can't argue that if we have to keep selecting so much that we've crossed over that threshold.
But you're forcing it.
The trials are not fixed. I don't go out there and say I'm going to grab 20 and count.
Until you.
I'm going to find 20, and I don't care how long it takes to get it. That's what makes this different. You haven't started by saying, I'm going to gamble 5 times because I know I'm only going to win 1.1 time out of 5. This is, I'm going to keep gambling until I win. See the difference there? The difference is I've got 5 $1 bills in my pocket, and I'm going to play until they're gone, and I'm going to see what happens. This would be, I've got 5 $1 bills in my pocket and an ATM card. And I'm going to keep gambling until, well, let's not talk about that. See the difference? You haven't fixed the number of trials. You haven't fixed the number of trials on this one. That's what makes this non-binomial. The last one was, and it sounded almost identical, but the last one, you weren't guaranteed 20 guys with RGCB. You were guaranteed 20 guys, and you were going to count how many of them had red-green color blindness. How many guys total is this going to take?
You don't know?
You don't know yet. You could average, this is called a geometric distribution, FYI. You'll see it on your quiz next week if you're interested. You can figure it out, but not with the information we have right now. You don't know right now. You can figure it out average-wise based on that 7%, couldn't you? Go ahead.
Would that be the same as saying you're going to keep going and get 20 chicks until all 20?
Yes, which is different than sending Max in with a box and saying, fill this with 4 birds. That's why I don't say things like, fill this box with birds. Because he's clever. He will figure out how to get 30 birds in that box. And most of them will make it on the trip home. Good, very good connection, very good connection. Here's a bastard one for you. Here's a bastard one for you. Mostly because I can't do it this morning.
No.
I can almost do it. It sounds like the first one. It was binomial, doesn't it?
No, it's not.
Except for the fact that, Carly,
Because the sample size is too small, so the probability changes.
now there aren't even 10 guys in the room right now. But even if there were 10 guys in the room right now, that would only be like 25 or 30 people total in the room, correct? If I start pulling people out of that small a population, I'm changing the percentage of what remains measurably. This isn't the 20 dudes out of 150 million. This is 10 dudes out of 30. That's a huge percentage change every time I remove one.
It wouldn't be out of 30, it would be 10. If there were 10 men in the room, it would be 10 out of 10.
Well, no, but I'm selecting. Oh, shit, that's right, because I'm not selecting from the girls.
Yeah.
Damn, I need more than 10 guys to select 10, don't I?
Right.
11. I thought there was 10 guys registered in this class. Actually, I think about it. Interesting. Think about it. There's a quiz at 244 about that one next week, actually. It's a theory one of my students had a couple years ago about the genders of certain professors. Yeah, whatever. This is hypergeometric again, if you needed to use the tool for hypergeometric. Cool? All right. I want to close. We have enough time for one more experiment. Somebody said I should pay my son for all the times he makes an appearance in the class. I keep saying it's genius.
Does he put his own shoes on?
He demonstrates such wonderful applications of everything we talk about. It looks like you guys are noticing exactly what I wanted you to notice. Summer 2010, four summers ago, 3.5 summers ago, I guess, or 3.5 years ago, Max discovered Crocs. And the first time he put them on, that's that left picture. That was the first time he put them on. Looks up, I said, wink. That's how he used to wink. And he, very cute. I made them make a big deal about it. I said, okay, he's got the shoes on the wrong feet. That's really cute.